Today, I'll explain Newton's first law of motion in a very simple way.
Newton's first law says an object will remain at rest or keep moving straight unless a force acts on it.
If something is not moving, it stays at rest. If it is moving, it continues moving straight.
When I push this book, I apply a force. That force causes a change in motion. This effect is called inertia. It's why your body moves forward when a vehicle stops suddenly. So remember, without force, motion does not change. That is Newton's first law. Physics becomes easy when you understand it.
Now let's talk about Newton's second law of motion. This law explains how force, mass, and acceleration work together. Newton's second law says that force equals mass times acceleration. That is, F equals ma. Mass is how heavy an object is. When you push a lighter object, it accelerates more than a heavier one. The more force you apply, the faster the object accelerates. So, greater force means greater acceleration. Pushing an eraser is easy, but pushing a heavy book needs more force to get the same acceleration. So remember, acceleration depends on both force and mass. That is Newton's second law of motion. Simple. Let's solve this why question using Newton's second law. From the question, the mass is 2 kilograms and the force is 10 newtons. We use the formula F equals ma. To find acceleration, we make A the subject. Substitute the values into the formula. 10 divided by 2 gives 5 meters per second squared. This means that object speed increases by 5 meters per second every second. In exams, always show your steps and write the correct units. Good morning, class. Today, we are learning Newton's third law of motion. This one is very easy to understand. Newton's third law says that for every action, there is an equal and opposite reaction. What this means is simple. When one object pushes another object, the second object also pushes back. If object A pushes object B will push object back with the same strength, but in the opposite direction. When I push the desk also pushes me back. That pushback is the reaction. This is why when you jump, you push the ground down, and the ground pushes you up. So remember, every action has an equal and opposite reaction. That is Newton's third law of motion. Let's answer this WAEC or NECO question using Newton's third law. This question is testing Newton's third law of motion. When the gun fires, it pushes the bullet forward. That push forward is the action. The bullet also pushes the gun backward with equal force. That backward movement is called recoil. In exams, always mention action and reaction and say they are equal and opposite. That is why a gun recoils backward when a bullet is fired. Good day. Today, we are learning Newton's universal law of gravitation. This law explains why objects attract each other. Newton's universal law of gravitation says that every two objects attract each other. The bigger the objects, the stronger the attraction, and the farther apart they are, the weaker the attraction. This formula helps us calculate the force of attraction between two objects. This is why objects fall to the ground. The earth attracts them because it has a very large mass. When objects are close, gravity is stronger. When they are far apart, gravity becomes weaker. So remember, gravity depends on mass and distance. That is Newton's universal law of gravitation. Let's solve this WAEC or NECO question on the law of gravitation. First, write out the values given in the question. Next, write the formula for Newton's universal law of gravitation. Now substitute the values into the formula. After calculation, the gravitational force is 8.34 times 10 to the power minus 10 newtons. This force is very small because gravity between small masses is weak. In exams, always show your steps and write the correct unit. Again, let's solve this WAEC or NECO question on the law of gravitation. First, write out all the values given in the question. We use Newton's universal law of gravitation. Now substitute the values carefully into the formula. After calculation, the gravitational force is approximately 9.8 times 10 to the power 3 newtons. This force is what keeps the satellite attracted to the Earth. In exams, Earth and satellite questions follow the same steps. Thank you for watching. Please subscribe to our YouTube, follow us on Facebook at Learn Science with Nachi, and turn on notifications so you will never miss our videos.